Hello everyone, my name is Victor Beck. I'm a second year PhD student in the Interdisciplinary Health Sciences program. My advisor is Dr. Tess Hilgenkamp, and my presentation will be about lower oxygen uptake efficiency slope with a similar VE/VCO2 slope in individuals with Down syndrome. So to start off, a little bit of background about individuals with Down syndrome and their aerobic capacity, because we know that individuals with Down syndrome have very low aerobic capacity or VO2 peak compared to individuals without Down syndrome. And as a result of this, individuals with Down syndrome often experience exercise intolerance. And this is important because VO2 peak is a predictor of future health, as people with a low VO2 peak have a higher risk for all-cause mortality. And additionally, VO2 peak is an indicator of one's ability to independently complete functional tasks such as grocery shopping, getting out of bed, showering, etc. So therefore, it's very important to maintain sufficient levels of VO2 peak, both for your health and for your ability to live independently with a decent quality of life. So because of the importance of VO2 peak, and because it's so low in individuals with Down syndrome, there's already extensive research trying to explain why individuals with Down syndrome have such a low VO2 peak. And by now we know that autonomic dysfunction and certain cardiovascular limitations contribute to the low levels of VO2 peak in individuals with Down syndrome, as individuals with Down syndrome have a lower maximum heart rate and they have impaired control of heart rate and blood pressure in response to exercise, exertion, and other forms of stimuli. But it doesn't tell the whole story yet. So more recently, research has suggested that individuals with Down syndrome might experience less efficient respiration. And with respiration, I'm talking about the exchange of oxygen and carbon dioxide to facilitate energy production. And this happens both at the pulmonary level and at the mitochondrial level. And we have reason to believe that in individuals with Down syndrome, respiration at both these levels might be less efficient than in people without Down syndrome. So in order to say something about respiration, we identified two variables that we can collect during exercise, and those are oxygen uptake efficiency slope and the ventilatory equivalent of carbon dioxide slope, or the VE/VCO2 slope. And the oxygen uptake efficiency slope says something about the efficiency of oxygen extraction and utilization, and a lower oxygen uptake efficiency slope indicates less efficient respiration. And the ventilatory equivalent of carbon dioxide slope says something about the efficiency of carbon dioxide clearance, and the higher VE/VCO2 slope indicates less efficient respiration. And both of these variables are also associated with VO2 peak and all-cause mortality. So they make for excellent variables to try and contribute to the literature of why individuals with Down syndrome have such a low VO2 peak and the possible role of respiration in this story. So that's why we wanted to determine if oxygen uptake efficiency slope and VE/VCO2 slope during a cardiopulmonary exercise test are different between individuals with and without Down syndrome, in order to hopefully explain why people with Down syndrome have such a low VO2 peak, which could help in designing exercise programs and helping them to maintain sufficient levels of VO2 peak. So in order to answer that question, we did a retrospective analysis of a data set that included 21 healthy individuals with Down syndrome and 30 healthy individuals without Down syndrome. They all performed a cardiopulmonary exercise test or a graded maximum exercise test. And from that test, we extracted VO2 peak, or peak oxygen uptake efficiency slope, and the VE/VCO2 slope. And the oxygen uptake efficiency slope is the slope between oxygen uptake from the start of the test until the moment of VO2 peak, and the logarithm of ventilation. And ventilation is the amount of total air you're breathing in per minute. Similarly, the VE/VCO2 slope is the slope between ventilation and the carbon dioxide production per minute. So what we found, according to the expectations, individuals with Down syndrome had a lower VO2 peak than individuals without Down syndrome. both when we express VO2 peak as a relative value corrected for body weight, and when we look at VO2 peak as an absolute value in liters per minute. So that was a nice confirmation that our data set was representative of the general population of people with Down syndrome. More interestingly and more unexpectedly, when we look at oxygen uptake efficiency slope and VE/VCO2 slope, we see that individuals with Down syndrome have a lower oxygen uptake efficiency slope than individuals without Down syndrome, indicating a less efficient respiration. But when we look at the VE/VCO2 slope, we see that individuals with Down syndrome have a similar VE/VCO2 slope compared to people without Down syndrome, indicating that the respiration is not less efficient after all. So that was unexpected, because we would expect that if oxygen uptake efficiency slope is lower, that would translate to a higher VE/VCO2 slope, which of course didn't occur. And to understand what happened here, we need to have a little bit more of an in-depth discussion of the physiology behind the oxygen uptake efficiency slope and the VE/VCO2 slope, because both are influenced by the onset of metabolic acidosis and the volume of the pulmonary dead space. And a lower oxygen uptake efficiency slope indicates an early onset of metabolic acidosis and or an increased pulmonary dead space. But again, this should translate to a higher VE/VCO2 slope, which we didn't see. However, that doesn't necessarily exclude the onset of metabolic acidosis or the size of the pulmonary dead space as potential reasons for why the oxygen uptake efficiency slope was lower. So to explain that, we're going to dive even deeper into the physiology. And the formula I have here explains how the VE/VCO2 slope is the product of the interaction between the partial pressure of arterial carbon dioxide, the pulmonary dead space, and the tidal volume. And the partial pressure of arterial carbon dioxide is the partial pressure of carbon dioxide in arterial blood, and the tidal volume is the amount of air you're breathing in with one single breath. And when we look at that formula and when we look at our results, we saw that individuals with Down syndrome had a lower peak tidal volume than individuals without Down syndrome. So in order to maintain a similar VE/VCO2 with a lower tidal volume, that means that either the partial pressure of arterial carbon dioxide or the pulmonary dead space, or both, are different in individuals with Down syndrome. Unfortunately, we didn't collect these two variables, so we can't really answer that question. But based on other variables we collected and based on previous research, we can try and explain it at least a little bit. So the partial pressure of arterial carbon dioxide is linked to the onset of metabolic acidosis, where a higher PaCO2 is linked to an early onset of metabolic acidosis. And based on our results, we don't have a strong reason to believe that individuals with Down syndrome have an early onset of metabolic acidosis, but there's also research contrasting that, so we're not sure on that part yet. Also, when we look at the pulmonary dead space, based on previous research, we have reason to believe that individuals with Down syndrome do have a increased pulmonary dead space, but again, we don't know for sure, and we don't know the role of pulmonary dead space in individuals with Down syndrome on their respiration efficiency. So to conclude, unfortunately, we didn't collect all the necessary variables to provide conclusive evidence on the role of respiration on the low VO2 peak in individuals with Down syndrome. What we can say is that exercise intolerance in Down syndrome is likely related to some limitation in the efficiency of respiration, either at the pulmonary level or at the mitochondrial level, or at both. We just don't know yet. So thanks for your attention. If you have any questions, I'd be happy to answer them. You can email me your questions at victor.beck@unlv.edu. Thank you.